we are simplifying radicals where there are variables. So let's just start off with something easy. What's the square root of x squared?
X.
Just x, right? What's the square root of x to the fourth?
37.
X squared. What is the square root of x to the sixth? X to the third. So a lot of people get hung up on this because I know the square root of 4 is 2, but actually has nothing to do with that. It's because x squared times x squared gets me back to x to the fourth. Isn't x cubed times x cubed really x to the sixth? Right? You're just adding those exponents. So the square root of x to the 10th, for example, would be x to the 5th. So basically, I can take the square root of any exponent that's even very easily, right? The square root of x to the 48th would just be x to the Thank you. So what happens when I try to take the square root of an exponent that's odd? It doesn't work nicely, but I can still simplify it. Okay, so if I wanted to do, I don't know, let's say I wanted to take the square root of x to the 11th. Well, 11 is not an even number, so I can't just take half of it very easily. But what I can do is I can break this up into the largest perfect square that does go into x to the 11th. Which is weird to think about it, but isn't it just x to the 10th? Isn't x to the 10th a perfect square? Can't I take the square root of x to the 10th? I can take the square root of any variable raised to an even exponent. So what I'm going to do is I'm going to split this up into the square root of x to the 10th times the square root of x to the 1st. Wouldn't that get me right back to x to the 11th? Right? X to the 10th times x to the 1st really is x to the 11th. But I can take the square root of x to the 10th. What is it? It's just x to the 5th. So that's how something like that would split up. So if I'm trying to take the square root of any odd exponent, doesn't matter what it is, I just go down by 1 when I split it up. I go down by 1 and then I'd have x to the 1st here. That will always be a perfect square, and that's what's going to come out. So let's try another one. Say I want to do x to the, I don't know, how about 23rd? So everybody simplify for me the square root of x to the 23rd. Did we get it? Once you get it, they're really easy. So 23 is not a perfect square, but what is? X to the 22nd. You just always just go down by 1. And that would be x to the 1st. I do know the square root of x to the 22nd. It's just x to the 11th. Bless you. That's it. That's my answer.
Here's a bell.
Yeah.
Yeah, I need to borrow it. From my last group.
You have a bell, but not a glove?
Yeah.
Go figure. I'm an angel, not a witch. You get it? What happens every time a bell rings?
We all just run away.
No, an angel gets its wings. God.
That was church bells.
You guys are so bad. Anyway. So, square roots are easy-ish. Well, maybe. I don't know. Let's put it all together. Say I ask you to take the square root of 50, x to the 6th, y to the 9th. Okay, so hopefully we got an answer. This is really 3 little mini problems all in one. So one thing that I like to do first is I actually split it up into its 3 little compartments. So I'll deal with the square root of 50, I'll deal with the square root of x to the 6th, and I'll deal with the square root of y to the 9th, kind of all separately. So 50 is not a perfect square, but 25 is, and it divides in evenly twice. So that whole thing just becomes 5 times the square root of 2. The square root of x to the 6th, what is that? It's just x to the 3rd. And then the square root of y to the 9th. Don't get caught up here. It's not y to the 3rd. Right, you got to split that up. I have to go down to y to the 8th and y to the 1st. The square root of y to the 8th is y to the 4th times the square root of y. Once I'm here, and I've done my 3 little mini problems, anything that's not inside of a radical will get all multiplied together and goes out in front. So that would be 5x cubed y to the 4th. And then anything that is in a radical will get multiplied together, and then it just stays under one radical together, square root of 2y. So this is how I would write my answer. You did this in Algebra 1. I don't know if you remember or not. Do you remember? Oh, okay. Well, if you didn't, or don't remember, seem easy enough so far? Just doing 3 little mini ones. So I'll give you one more try before we do a different root. Say I asked you to do the square root of, oh, how about 128 x to the 13th. Whoops, thanks. And let's do y to the 50th. Alright, so we're going to try the same thing. I break it up into its 3 pieces, 3 little mini problems here. What is the largest perfect square that goes into 128? 64, and it goes in twice. So that becomes 8 root 2. Okay? X to the 13th, that's not a perfect square. So I have to split it up into x to the 12th and x to the 1st. The square root of x to the 12th is x to the 6th. And then the square root of x just stays in there. Square root of y to the 50th. Is that a perfect square? Yes. Any even exponent is a perfect square. So the answer to that is just y to the 25th. So now I just multiply everything not in a root. 8 x to the 6th, y to the 25th, and then everything that is in a root. Okay, so that's square roots, right? Well, how do we handle cube roots? We already did cube roots with numbers, so let's talk about cube roots with variables. All right, so let's start with this. What do you suppose the cube root of x cubed is? Someone said it. Isn't it just x? Yeah, it's just x. The cube root of x cubed is just x. It's asking me, what do you cube to get x cubed? X. So, what do you suppose this is? What number would I cube to get x squared to the 6th? X squared, right? X squared times x squared times x squared. Aren't you just adding those exponents? So we get 2 plus 2 plus 2. Yeah. Or I could do x squared to the 3rd power. It still gets me x to the 6th, however you do it. All right, I'm seeing some interesting little pattern here. What's the cube root of x to the 9th, do you suppose? X to the 3rd. Huh. So just one more to drive the point home. The cube root of x to the 12th must just be x to the 4th. Are you seeing some quick way to, if I have these numbers, what do I do with these numbers to get this number? Yeah, I just take the exponent and I divide it by the index, and that gives me my answer. It works for squareds too, right? Remember, there's a teeny tiny 2 on all these little bird perches. 6 divided by 2 is 3. 10 divided by 2 is 5. 48 divided by 2 is 24. So you can just take your exponent and divide it by the index, and you'll always get the answer. Yeah, well, that's great, except when the number in there is not a multiple of 3. So it doesn't divide by 3 evenly. What in the heck are you supposed to do then? Let's say, for example, I want to take the cube root of x to the 17th. I can't do 17 divided by 3 evenly. So remember, when I try to do it for square roots, right? 11 doesn't divide by 2 evenly. So what did I do? I broke it up into something that does divide by 2 evenly, and then whatever's left over. You see that? So I kind of work the same way. I have x to the 17th. If I go down to x to the 16th, can I divide 16 by 3 evenly? No, so that won't help me any. So I'm not going to break this up into the x to the 16th and x to the 1st. But what if I broke it into x to the 15th and x squared? Can I divide 15 by 3? Yes. So the largest perfect cube that goes into x to the 17th is actually x to the 15th. Okay, Miss Sabia, so you're saying that for a perfect square, if it's odd, you just go down by 1. And if it's a cube root you're trying to get, you go down by 2. I didn't say that. Sometimes you do and sometimes you don't. It depends. You have to go down to the next multiple of 3, right? Because if that number had been 19 and I go down by 1, well, 18 I can divide by 3, so I would have only gone down by 1. Here, I have to go down by 2 to get to my next multiple of 3. Does that make sense? You always have to go down. You can't go back up. You could, but it's really weird, and then it involves negative exponents, and you don't want to do that. So don't do it. So we're going to go down. I'm going to split this up into the cube root of x to the 15th and the cube root of x squared. Right? X to the 15th times x squared is still x to the 17th, but now I can take the cube root of this one. What is the cube root of x to the 15th? It's x to the, someone said it, 5th. And then I just leave this, the cube root of x squared. That's my answer. I know, it feels weird, but that's the idea. So let's try cube root of, how about x to the 34th? Well, 34 doesn't divide by 3 evenly. So I'm just going to keep going down until I hit a multiple of 3. So go down 1, 33. Is that a multiple of 3? Yeah, so this time I only have to go down once. right? The cube root of x to the 33rd is x to the 11th. And then that's just going to stay as it is. Right there. Thanks. Does that make sense? Okay, so you try this one. Find for me the cube root of x to the, oh, I don't know, how about 23rd? Okay, we got an answer? So, I had to split this up into the cube root of x to the, what goes right here? Yes, thank you, 21. So then over here is, yes, a 2. So the cube root of x to the 21st is x to the 7th, and then that stays as it is, cube root of x squared. Did you write this as your answer? Perfect. So when I do the other roots, it's the same exact idea. You just have to account for the root that you're looking at. So for example, if I wanted the 4th root of x to the 10th, I can't do 10 divided by 4. So go down 1. Can you do 9 divided by 4? No. Can you do 8 divided by 4? Yes. So this one I'd split up into the 4th root of x to the 8th and the 4th root of x squared. So this just becomes, what's the 4th root of x to the 8th? X squared, right? You just do the exponent divided by the index. And then that just stays. How do you know if it stays? Because if you divide this, right, you're going to get a fraction. If the fraction's less than 1, there's nothing for you to do. It's already simplified. You can't make it any better than it is. So try, how about the 4th root of x to the, how about 19th? Simplify that one for me real quick. Okay, you got it? Maybe? I can't do 19 divided by 4 evenly. I can't do 18 divided by 4. I can't do 17 divided by 4. I can do 16 divided by 4. So then what's this one? X to the 3rd. Exactly. This just becomes x to the 4th, and that just stays. 4th root of x to the 3rd. Okay, so no matter what root we're talking about, if it's the 5th root, keep going down until you hit a multiple of 5. So maybe you have to go down once, maybe you have to go down twice, 3 times, 4 times. You should never have to go down 5 times, because then that means that you're already at a multiple of 5 when you started. Okay, there's one more little piece that goes into this, which is weird, and it has to do with absolute value bars. Okay, Those of you that are still taking notes, that are still with me, still paying attention, you're going to put a big old star. This is important. Okay, ready? So here's how it goes. Anytime your index is even and your exponent is even, and the answer has an odd exponent, you need absolute value bars. What? What are you even talking about? You're so weird. Don't worry, I'm going to explain it. This, we like to say as a little chant, even, even, odd. Even, even, odd. That's how you remember this little bit. So what I'm basically saying to you, if I wanted to do something like, let's see if I can get this example over here at the same time. Say I wanted to take the square root of x to the 4th. I'm just kidding, 6th. What's the square root of x to the 6th? X to the 3rd, right? But there's a problem here. Let's pretend that x was -2. Okay? If I plug in -2 on the right-hand side, what would I get out? If x is -2, what's -2 to the 3rd power? -8. So I get -8 on this side. On the left-hand side, which is supposed to be the exact same thing, right? If I plug in -2 on this side, right, I do -2 to the 6th power, which is 64, and then the square root of 64, without any sign in front of it, is a +8. Well, that's a problem because +8 does not equal -8. So this rule covers that for us. So if my variable happens to be negative, I have this weird thing where it doesn't work out. So if you have an even index and you're taking the even index of an even exponent, and what comes out is an odd exponent, here's what you have to do. You have to put absolute value bars around that answer. Yep. Yeah. So it's only for even, even, odd pieces. Okay? Even, even comes out odd. So if I asked you the square root of x to the 4th, it comes out as x squared. You don't need them here because that's even, even, even. Anytime I'm taking a cube root or a 5th root, I automatically don't have to worry about it because my index is not even. It's this weird little thing, but it accounts for times when this happens. So on your homework, you're going to see, it'll say simplify, use absolute value signs when necessary. So I wouldn't need it on 11. I wouldn't need it on 12. Let me find one where you would need it. Which one? Well, you actually can't take the 4th root of m squared, so you would just leave it. Even, wow. Maybe 24 will work. Hi. Yes. Thank you. Bye. Wow, I think the only one that's on here is going to be 4. I mean, 24, sorry. Let me make up another example. Say you were trying to do the 4th root of x to the 20th. What's that going to come out to be? X to the... What's the 4th root of x to the 20th? X to the... To the what? Fifth, thank you. You just do 20 divided by 4 to the 5th. Would I need absolute value bars here? Yes. Even, and it came out odd. So I have to put absolute value bars around that answer. It's this little thing, but it's important when my variables, because I have no idea what x is. It could be a positive number, it could be a negative number. I don't know. Sometimes they avoid all this by saying at the top of paper, like, assume all variables are positive numbers. Then you don't have to worry about absolute value bars. But that's not always the case. Sometimes you do have to worry about them. All right, so for your homework this evening, you've already done 1 through 10. How about if we just do, I don't know, you want to do evens or odds on the back? Odds? Sounds good to me. So, odds on the back. I'm going to help you even, let's do number 13 together since we have a moment. This one's a 4th root. So, first thing I'm going to do is I'm going to break this apart, and I'm going to deal with the 4th root of 32, and then I'll have the 4th root of m squared. The 4th root of 32. Is 32 a perfect 4th? Look at your list. Perfect cubes. I do not see 32 in this list. Whoa. But the largest number in this list that goes into 32 is 8. So this will split up into the 4th root of 8 times the 4th root of 4. The 4th root of 8 is, oh wait, that was cubes. I'm sorry. We weren't looking at perfect 4ths at all. There's my perfect 4ths in purple. Sorry. So what goes into 32? 16. Sorry. So that should be a 16 and a 2. The 4th root of 16 is just 2. And then that stays. Now, this here, I can't simplify that anymore. 2 divided by 4 is already a fraction less than 1. It's already simplified. There's nothing else I can do with it, so it just stays 4th root of m squared. It's like if you try and take the square root of x. There's nothing I can do with it. That's as best as I can get, right? So now when I write my answer, everything not in a root goes out in front. Everything that is in a root gets multiplied together. And it looks like that. I don't have to worry about the even, odd bit here because it didn't come out odd. That didn't simplify. So I get to leave it. Okay. So, odds for homework. Do you feel like you can do them? All right. Give them a shot. We'll talk about them more tomorrow.